Lesson 6.3, Difference of Squares. One of the very first polynomials that we will learn to factor is called the difference of squares. First, we need to understand and be able to recognize what a difference of squares is. A difference of squares is one perfect square minus another perfect square. So, for example, x squared minus 16. X squared is a perfect square, and so is 16. The difference of squares factors very easily if you learn the pattern. If you have a difference of squares, it will factor like this. So if I have a squared minus b squared, those are both perfect squares. I take the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. So for our first example, we had x squared minus 16. The square root of x squared is x. The square root of 16 is 4. So this will factor as x plus 4 and x minus 4. Okay, so we'll have some more examples. X squared minus 9. The square root of x squared is x. The square root of 9 is 3. So x plus 3, x minus 3. Here I have the square root of n squared is n. The square root of 289 is 17. So I'll have n plus 17 times n minus 17. Now this has a number in front of it, but 4 is also a perfect square. So if I take the square root of 4x squared, I'll have the square root of 4, which is 2, and then the square root of x squared, which is x, so 2x. And the square root of 25 is 5. So I have 2x plus 5, 2x minus 5. And finally, 9b squared, the square root of 9 is 3, the square root of b squared is b, and then again the square root of 25 is 5, so 3b plus 5 times 3b minus 5. Now what I would like you to do is pause the video, work these 4 problems out, and then when you're finished, unpause and compare your answers to the answers I've put in and see how you do. Okay, so let's check your answers. You should have x plus 2, x minus 2, x plus 13, x minus 13. Now the square root of 1 is 1. I hope that didn't throw you off. So square root of 16 is 4, so 4b plus 1, 4b minus 1. And then this one had the variable at the back, but it's still a perfect square, so I do 1 plus a, 1 minus a. Okay, so when a problem looks like a difference of squares, but it is not a set of squares, for example, 3x squared minus 27, or 8x to the third minus 50x, our first step is going to be to factor out the GCF. So between a 3 and a 27, I can factor out a 3, and that leaves me with x squared minus 9. Between an 8 and a 50, I can factor out a 2, and here I have 3 x's and here I have 1, so I can take out 1x, and I'm left with 4x squared minus 25. Then, after we've factored it, we check to see if it's a difference of squares. Here I have a difference of squares, here I have a difference of squares. If no, the problem is factored. If yes, we factor the difference of squares. So let's take another example really quickly. Let's say this was not a 27. Let's say that was like a 15. And I pull out a 3 and I'm left with x squared minus 5. once I get to this point, 5 is not a perfect square, so I would be done. But because I did have a 27, I now have a difference of squares. So I factor that. The square root of 3 is 9. Or sorry, the square root of 9 is 3. And then here I have the square root of 4x squared is 2x. And the square root of 25 is 5. So I have 2x plus 5 and 2x minus 5. And then we have completely factored. So let's take some examples. Here I can take a 2 out of both terms, and I'm left with x squared minus 9, which is a difference of squares. So I take the square root of each, and plus and minus. Between 150 and 216, that's going to take maybe a little bit of work. So I'm going to use my factor trees. 150 is 2 times 75, 206, and then I'll 3 times 25, and 5 times 5. 216 is 2 times 108, which is 2 times 54, which is 6 times 9, which is 3 times 3. They have a 2 in common. They have a 3 in common. So I can take out that 6. And what I'm left with, I pull out the 6. I take 150 and I divide it by 6, and I'm 25k squared minus 216 divided by 6, which is 36. And now I have two perfect squares. The square root of 25k squared is 5k. The square root of 36 is 6. So I have 5k plus 6 and 5k minus 6. 3 and 75 will both divide by 3, leaving me n squared minus 25. So I take the square root of each, and I plus and minus. And then 24 and 54 will both divide by 6. And I have 3 x's and 1 x, so I can pull out a 6 and an x, and I'm left with 4x squared minus 9. So I take the square root of the first and the second, and I plus and minus. Now you'll notice I still carry this down, whatever I factored out. It doesn't go away just because you factored it out. It's still a part of the expression. So why don't you pause the video again, try to factor these, remembering to factor out the greatest common factor first, and then factor the difference of squares. And then when you've finished, unpause the video and check your answers. Okay, so you'll notice I needed to make a factor tree to find my 4. I factored the two numbers and they had two 2's in common, which left me with 49 and 36, which I was able to factor to 7n plus 6 and 7n minus 6. 20 and 45 divided by 5, leaving me 4a squared minus 9. So I had 5 times 2a plus 3 and 2a minus 3. 6 and 96 divided by 6, leaving me with a squared plus 16b squared, which I was able to factor into a plus 4b and a minus 4b. And then 54 and 6 both divide by 6, leaving me with 9v squared minus u squared, which I was able to factor into 6 times 3v plus u and 3v minus u.